Hello friends, welcome once again to ASM for online math class. In this video, I'm going to show you how legends solve implicit differentiation. Okay, how legends differentiate implicitly. Make sure you watch this video to the end because first of all, I'm going to differentiate it implicitly the normal way it is done before I now show you how I do my own things when it comes to implicit differentiation. Okay, in implicit differentiation, one thing you need to understand there is that once you differentiate y, you have to attach the y over the x because normally you are differentiating with respect to x. Therefore, when you differentiate y, which is not x, you have to attach dy dx. Remember, implicit differentiation occurs whenever x and y are mixed up like this implicitly, unlike the explicit one where y is staying alone and x is staying alone. In fact, in the explicit differentiation, y is always the subject of the formula before you now differentiate with respect to y, dy dx. But in this time around, you find out that you differentiate implicitly when x and y are mixed up in this manner. Okay, now to do that, remember again that anytime you differentiate y, you have to attach dy dx. And sometimes you might meet a product rule, just like where you are having x and y mixed up together here. This is product because it is assumed that 2x is multiplying y, so you still apply your product rule of differentiation. Okay, now when I differentiate x squared, it's gonna be 2x because the power will come down, then the power minus 1 as usual, and when 2 minuses 1 it will give us 1. Therefore I can just call this 2x plus, this is product rule. I will differentiate x, keep y constant, then differentiate y and keep x constant. That is product rule. So if I differentiate x now, I'll have, that is differentiating 2x, I'll have just 2. Then keep y constant, that is 2y, plus I'll keep 2x constant and differentiate y. If I differentiate y, it will give me 1, but I'll attach dy over dx because anytime I differentiate y, I will put dy dx like I said. Plus, if I differentiate y squared, it will give me 2y, but I will still attach dy over dx. Any constant you differentiate is always 0. So this is now 2x plus 2y plus this is 2x dy over dx plus 2y dy over dx equals 0. If you look up here vividly, you will see that dy over dx is common here, so you can factor it out. So I can call this, I can put them together, then put this together. Now let me take this to the right hand side. If I take it to the right hand side, this will now come first. But before that, dy dx is common, so I'll factor out dy dx. So dy over dx into what is left here is 2x plus what is left here is 2y equals this whole term here crossing over will turn to negative 2x plus 2y, because when a positive term or expression crosses the equality sign, it changes to negative. Now at this point, I have to divide both sides by 2x plus 2y so that dy over dx will stay alone, because our task is to get dy over dx. That is the differentiation. So divide both sides by 2x plus 2y by 2x plus 2y. Now this will cancel out, this will cancel out, and when this divide is easy to giving us negative 1, because the something divided something is 1, and there is a negative sign here. So therefore dy all over dx will give us negative 1, and this is just the differentiation of this particular equation or this particular function, and that is how we've got negative 1. This is normal way of doing implicit differentiation, but this particular function, there is a way I'm going to do it now, though it's not always applicable in all cases, but for this particular problem, watch how I'm going to solve it. Okay, now Now this is the way I'm going to solve this. You know that this is a quadratic equation. So if I want to factor out this, I'll use x squared to multiply y squared. It will give me x squared y squared. What are the two things you multiply to get 2xy? If you add, you get x squared y squared. That is what you ask yourself. First of all, x squared times y squared is x squared y squared. So what are the two things you multiply to get x squared y squared? And if you add them, you get 2xy. Of course, it's going to be xy and xy, positive, positive, because xy times xy is x squared y squared, and xy plus xy will give you 2xy. So you shall now have x squared plus, use this xy and xy to replace 2xy, plus xy plus xy plus y squared equal to 5. Then considering the first two terms, x is common, so you have x into this, divide this will give us x, plus xy divided by x is y, plus coming here, y is common, you factor it out, xy divide y is x, plus y squared divide y is y, equals 5. As you can see, x plus y is common, so you have x plus y, which is common. I factor it out, and what is still left here? X plus y, then equal to 5. Remember, x plus y is double, meaning that you can call it x plus y all squared equal to 5. Then to clear this square, you can take the square root of both sides. So you shall now have that x plus y is equal to square root of 5, because to clear square, you take square root. Then let us make y the subject of the formula. If I make y the subject of the formula, I will now have that y is equal to root 5 minus x. When x comes here, it becomes negative. So we've now formulated a function. We've now found a function which is y is equal to root 5 minus x. Then you can now easily take your dy dx. So you shall now have that dy over dx implies whenever you differentiate any constant, square root of 5 is a constant, it will give you 0, minus, if you differentiate any letter like this, x will give you 1. Therefore, dy over dx will give us 0 minus 1 is minus 1. You can see that in both cases, we got minus 1 as the answer.